Lots of calculator wrestling. That's fantastic.
Thank you.
All right, today is January 27th. Hope you guys had a nice weekend. January's almost over, ladies and gentlemen. Let's just bask in the glory of January almost being over. Okay, today we're doing much the same that we did on Friday. Again, we're finishing up that worksheet from Friday. And on Friday we said, hey, if I have a square root, it turns out that I can rewrite that. What can I rewrite that as? Instead of using the radical, what can I do instead? 1/2. Yes, the 1/2 power. So the index here is 2. It has a power of 1. And so we can rewrite it using rational exponents. And it turns out that rational exponents are super nice to help us solve for x. All right, we did the whole reciprocal power thing, and that was really, really nice and convenient for us. So we're going to do a lot of the same stuff today. It's just that today we end up with some quadratic equations. This is quadratic. How do I know this equation is quadratic? Because x being squared makes it a quadratic equation. And anytime we have a quadratic equation, we want to make sure that it's set equal to 0, just like this one is. And then how do you solve a quadratic equation? Factor first. Yeah, factor that. So we're going to double bubble that equation. All right, so double bubble or factor. What times what is x squared? X times x. And then last times last has to be the last thing. What times what is positive 6? Positive 6 times positive 1. We also had 2 times 3. How do you know which choice? The one that gives you the 7. Really, you should always double check the rainbow. Remember that? Remember to check the rainbow. The rainbow being, hey, remember x times 1 is 1x, 6 times x is 6x, and when we add those together, that gives us that 7x in the middle. Once you have double bubbled, what do you need to do to actually isolate x? Set each bubble equal to 0. So we get x plus 6 equals 0, x plus 1 equals 0, and now we have equations we can solve for x. How do I get x by itself? Subtract 6, so we get x equals -6 for an answer, and over here I'm going to subtract 1. So we get x equals -1 for an answer. So this was just a refresher for solving quadratic equations. So today you're going to get a mix of linear equations that are easy to solve or quadratic where it's going to require some factor and solve. Okay? All right. So here you go. Example 1. Solve the equation. Check for extraneous solutions. And this is the big key. When we have all of these, what we call radical equations, and you can see it's got a radical, that makes it a radical equation. It's very possible that your answer is not going to work. Maybe you did all the math right, but when you plug it in, it just doesn't work, okay? And so we have lots of possibilities. We absolutely want to check our answers, and that's sort of the goal for today. Did you check your answers? You need to know how to do that using your calculators. Do it properly, checking properly, carefully. With Casios, make sure you're using parentheses in there. All right, so you can see here on letter A, we have a radical equal to a radical. And just like on Friday, I find radicals cumbersome. So if I have something under the radical, I'm going to rewrite that, and I want to use an exponent. What exponent can I use instead of this square root? What's the index? 2. And what's the power? 1. There's a little invisible 1 there. So what can I rewrite that radical? 1 over 2. Power over index. Power over index. So I can do the same thing on this right-hand side. Everything that's under the radical, I'm going to put in parentheses. And again, I can rewrite. So instead of seeing a square root, what can I use instead? 1 over 2. Again, power over index. Power over index. All right, so we can see that we're solving for x, but the x is currently trapped inside the parentheses. What do I do to get rid of the powers? Reciprocal powers, sure. So we're going to do the reciprocal power, which is 2 over 1, or just squaring both sides. I'm going to square the left side and square the right side. 1/2 times 2 gives me 2 over 2, which just goes away. And so I'm just left with 2x minus 1. Got my powers to cancel out. On the right, again, 1/2 times 2 cancels out and just leaves me with x plus 4. Is this linear or quadratic? Linear. How do I know it's a linear equation? Yeah, it doesn't have that square on it. It's just x to the first power. That makes them linear. So these are easy. Linear equations, you just want letters on the left. Linear, letters on the left. So I'm going to take this x and move it over. So I'm going to subtract x. 2x's minus 1x is 1x. And then what do I need to do with the 1? Add the 1. So I get x equals 5. That's a possible answer. But what I need to do is actually check that. And so I'm going to go back to my original equation and drop in the 5 for all of these x's. So square root 2 times 5 minus 1, and all that is under the radical. And I need to know, does it balance with the right-hand side? 5 plus 4 under the radical. So most of you guys in here have the Casio, so I'm going to use that. Okay. So in my Casio, this is just a square root. My square root button is yellow, so it's a shift. So I'm going to do shift square root. And then with parentheses, I've got 2 times the 5 minus 1. And that's all under parentheses there to make sure that it's all within the radical. And so that turns out to equal 3. So that left side equals 3. I'm going to do the same thing because I want to check for balance. So I need to check the right side. So I'm going to do, again, square root of 5 plus 4. And so that also gives me a 3. Does the left side equal the right side? Yes, it does, which means 5 works just fine. Okay? Check for balance is what we say. We want to know that the left and the right side are balanced. They're equal. Okay? All right. On letter A, the radicals were equal to one another, and it turned out when we had a radical equal to a radical, that was pretty easy to solve. The radicals just sort of cancel out. I would really like to see that happen here. Here I have a radical plus a radical. If you have the radicals on the same side, what we want to do is actually move it over to the other side. I want them to be set equal to each other if I can. So I'm actually going to subtract this whole 4th root of x plus 3. Oh, I can subtract that radical to the other side. So that's kind of nice. So I have the 4th root of 2x equal to the negative 4th root of x plus 3. So I just relocated it. Now again, just like before, anything under the radical, I'm going to trade that in for an exponent. What exponent is the same as a fourth root? 1/4. Very good. Power over index. Again, anything under the radical, I'm going to trade in for a power. So that, again, I can rewrite as a 1/4 power. So we can see that our x's are trapped. How am I going to unfree them? How am I going to free them? Fourth power, yeah, reciprocal power. We're going to do 4 over 1 or just 4. We're going to take the fourth power on the left-hand side, and you'll notice the fourth power on the right-hand side, and I am also including that negative. We are taking a fourth power of the entire right side of the equation. 4 times 1/4 cancels out, leaving just the 2x on the left. But on the right, I have to be a little bit careful here because I'm taking this negative, which is like a -1, -1 to the fourth power. That'd be -1 times -1 times -1 times -1. Does that give us a negative or positive result? Positive result. So that turns positive because there's an even number of negative signs there. So you gotta be a little careful. And then here, 1/4 to the power of 4, that actually cancels out. So that just leaves us with the x plus 3. So that's kind of nice. Don't really need the plus sign. Again, that cleaned up pretty nicely. I'm going to go ahead and subtract my x. Get my x's together. 2x minus 1x is x equals 3, possibly. But I really need to check this. So I'm going to go back to my original equation and plug in my value of 3 for all those x's. So to check this, I need the fourth root of 2 times 3 plus the fourth root of 3 plus 3. And that's supposed to equal 0. But I don't know. Let's see. To do a fourth root, if you have a TI, on the TI, under the math menu are your options for radicals. To do a fourth root, you need to put in the 4 and then go to the math menu. Whoops, did the wrong thing there. You're going to go to the math menu and go down to, here we have the xth root. And so you put in the 4 and then select the xth root. And you can see mine just put the 4 right in. It depends on how new your calculator is. So we can do the fourth root of 2 times 3. And you can see on my TI, the 2 times 3 is under the radical. That's really nice. Plus, again, the fourth root of 3 plus 3. I don't really need those. Again, the 3 plus 3 is under the radical, so I know that I got that right. That turns out to be 3.13. That's kind of weird. Was that what it was supposed to equal? No. All right, let me check on the Casio too. My Casio has an x root button right here. It's a second function. And again, I need to tell it the root needs to be a 4. So I'm going to put the 4 in and then do the xth root. And so that's putting the 4 into that x there for the fourth root. In my Casio, I need to use parentheses to make sure I do the 2 times 3 under the radical. And then plus, again, my fourth root of 3 plus 3. Again, the 3 plus 3 is inside parentheses, so it's under that radical. And that also gives me 3.13. Did it equal 0? No, that's not the right thing. Not 0 like it should, which means this is a false solution. So there's no real solution here. All right, and that's where we have to be super careful and check our answers. So why do you think we got a no solution on this one? What was the culprit? Where was the warning sign? The negative that we had to take to an even power. So anytime we have an even power or an even root with a negative, we need to be extra cautious. Okay? Check your answers is the moral of the story here. All right. What's different about C and D? They don't have a radical. Yeah, it's not a radical equal to a radical. These are going to be a little bit more challenging. So this only has a single radical. If x minus 12 is equal to the square root of 16x. Again, radicals are cumbersome and annoying, so I'm going to go ahead and trade that in. Everything that's under the radical, I can use what power? One half. Yes, 1/2. I can't do that on the left-hand side here. It works so well. I don't have one over there, so that stays x plus 12. I can see here my x is still trapped, so I need to get rid of this power. So what am I going to do? Reciprocal power, yeah. So 2 over 1 on the right-hand side, and also 2 over 1, or just 2 on the left-hand side. So we're going to square both sides. On the right, 1/2 times 2 is just 1, so we're left with 16x to the first power, or just 16x. This is very tricky. What do we have to do over here? What does x minus 12 quantity squared really mean? Yeah, 2 sets of them. So we have x minus 12 times x minus 12. There's 2 of them, and we have to multiply those together very, very carefully. Distribute. What's x times x? X squared. Then we have x times negative 12. Negative 12x. Distributing my negative 12. Negative 12 times x, again, is another negative 12x. And negative 12 times negative 12 is positive 144. So be very careful. It is not simply x squared minus or plus 144. Right? There's a whole middle term in there. X squared, negative 12 and negative 12 is negative 24x's plus 144. Be very, very careful. All right. So now this equation, is it linear or quadratic? Quadratic. These are quadratic equations. Just like in the warm-up question, we're going to set this equal to 0. So I'm going to subtract 16x's. X squared minus 3040 x's plus 144 is equal to 0. So it's set equal to 0. Now what do we have to do? Double bubble, yep. All right, 144, that's quite big, and I have to get a very large middle term. 144 I know is divisible by 2. 2 times 72, that's not going to work. But that's divisible again. What's 144 divided by 4 is 36. 4 times 36. Hey, that's a winner. X times x is x squared. What times what is positive 144? Negative 4 and negative 36. Good. Again, check the rainbow if you need to. Make sure we get that middle term. Now what do we do? Set them equal to 0. So x minus 4 equals 0. X minus 36 equals 0. Which means x equals what? 4 and x equals 36. Very good. All right. But again, we don't really know. Because whenever you have a radical, you need to check your answers. So here's the tricky part. We have 2 answers. We have to do 2 separate checks. I need to drop in 4 to both of those x's. Don't drop in a 4 on the left and a 36 on the right. We can't change our x value. Okay? So first I'm going to start by checking the 4. So I'm going to do 4 minus 12 on the left. And we want to see if it equals the square root of 16 times 4. So you see what I did there? I did 4 minus 12 on the left, and we're going to compare it to the square root of 16 times 4. So again, I use my calculator. 4 minus 12 I know is negative 8 on the left. On my calculator, square root of 16 times 4, that's positive 8. Did they equal each other? They do not equal each other, which means 4 is a false solution. They did not balance. 4 does not work. So now I need to test 36. So again, I'm going to go plug in 36 into my equation. 36 minus 12, does it equal the square root of 16 times 36? Well, what's 36 minus 12? 24, good. And now I want to check the right side there. So again, square root of 16 times 36, all inside underneath that radical. And I get 24. Hey, did those work? Yes, 24 equals 24. So this is our only solution right there. So it's really tricky. Sometimes both solutions might work. Sometimes one solution will work. Sometimes neither of them will work. All right. So we only have one answer there. All right, last one. We have the square root of 2x plus 28 equals x plus 2. Again, radicals are cumbersome. So I'm going to trade that radical in for exponent. That exponent would be 1/2. Power over index. Power over index. Equals the x plus 2. That x is trapped. What do I need to do? Get rid of the power by doing the reciprocal power on both sides. So I'm going to square both sides. 1/2 times 2 is 1, which leaves me with 2x plus 28. And over here, what do I need to do with the x plus 2 quantity squared? Write it out 2 times x plus 2 times x plus 2 and multiply. X times x is x squared. X times 2 is 2x. Distributing the 2. 2 times x is 2x again. And 2 times 2 is 4. Be very careful, ladies and gentlemen. That is where most people make mistakes. This is like the #1 common mistake in math. Okay. Clean that up a little bit. X squared 2x plus 2x is 4x's. Now what should we do? Subtract the 2x. Very good. And what else can we do? Subtract the 28 as well, yeah. So I have a 0 on the left-hand side. I really like that I have a positive leading term. That x squared is positive is really important. 4x minus 2x is 2x. 4 minus 28 is negative 24. Pay attention. There's definitely, I think there's one problem, maybe more, but one problem for sure on your homework. There's a greatest common factor. And if you can divide out like a 3 or a 4 or a 5 and make all the numbers smaller, that's going to be very, very helpful. Double bubble. X times x is x squared. What times what is negative 24? 6 and negative 4. 6 times negative 4 is excellent choice. And setting each bubble equal to 0, what does x equal? Negative 6 or positive 4. Yeah, good. And again, we need to check our answers. So we have two separate answers to check. Back in the original, I'm going to drop in my values in place of the x's there. So I have 2 plugging in a negative 6 plus 28 under the radical. And then on the right, I have negative 6 plus 2. Well, that I know, that's negative 4. So I'm going to check the left-hand side here under my radical. Whoops. So I want the square root of the quantity, 2 times my negative 6 plus the 28. You can see how I'm closing those parentheses. So all of that, those outer parentheses tell me that it's all under the radical. Really important. That equals 4. Does that work? No, does not equal. So that is a false solution. So now I'm going to test the 4. So under the radical, we have 2, plugging in the 4. 2 times the 4 plus the 28 underneath the radical there. And that's supposed to equal 4 plus 2. Well, I know 4 plus 2 is 6. That was easy. All right, so under the radical, parenthesis 2 times the 4 plus the 28. So again, all of that is under the radical. Lots of parentheses there. Be very careful. And that does equal 6. So that one works. So x equals 4 is the only solution. This was a huge thing, checking answers at the U of A. You have online math homework where you do math problems via computer and submit your answers electronically like that. But you also have a written assignment where it's just 2 questions. So it's like there's one and there's another. But for each of them, you have to include the check. You have to prove that your answer's right. Okay? So it's really important to be able to do that. Do you guys have any questions for me? All right, you are finishing up Friday's worksheets, doing the back side.